Cryptography is the method of encrypting information, such as a message or a program, for the purpose of securing the data for transfer, allowing the sender to ensure that only the selected recipient can access the information, and if an unwanted third party intercepts the data, it is illegible for them. The encryption of data is called encoding, and the deciphering of encoded data is called decoding. The most recognizable method of cryptography, the substitution method. To use the substitution method, you simply need a key commonly referred to as an alphabet key. This key exchanges the letters for either another letter, number, or symbol. For this demonstration, we'll use the number system. As you can see in the below alphabet key, you can see that each letter has been replaced or symbolized with a different number. This way, if you wanted to encode your message, all you need to do is substitute the letters with the corresponding value. For example, the expression, "Beware, the cat kills," translates to the number sentence 1, 20, 3, 7, 19, 20, 0, 17, 13, 23, 20, 17, 18, 7, 13, 17, 21, 10, 2, 2, 8, 0. You can then send the number sentence to a recipient, and as long as they have the same alphabet key, they will then be able to decode your sentence back into the original message. The substitution method, however, does have some issues. If you look at the encoded number sentence, you can see that the numbers repeat. For example, the letter E comes up 3 times, the letter A comes up 2, space comes up 3, dots come up 2 times, T comes up 3, L comes up 2. If the code was long enough, a hacker could solve and decode your message easily, especially using certain computer processors available in the modern world. This is where the use of matrix comes in handy. Let me explain. Using the same phrase and alphabet key as the message, "Beware the cats kill," translates into the same number sentence. However, this time we're going to take it a step further, converting code into a message matrix. This matrix needs to either have columns of the number 2, 3, or 4, as we need to create a second square matrix key which corresponds to the number of columns you have selected. A matrix needs to be a square, as matrices can only be inverted if they are a square matrix. For this example, we'll be using 3 columns. As you can see, the matrix is missing the bottom 2 numbers on the right hand side. These spaces need to be filled, so we'll add the numbers for space. This will not affect the message, but it will give you a full matrix. This will leave us then with an 8 by 3 matrix, 8 being for the number of rows and 3 for the number of columns. You can see from this image that there is a repeat of values. So what we need to do is develop a key matrix. This matrix for this example needs to be a 3 by 3 matrix. This can be filled with whatever numbers you would like. From this key matrix, what we need to do is multiply the original code matrix with the key matrix. Multiplying these numbers together will provide us with a new number sentence. You can see in this sentence that there is no repeat of values, making the code harder to crack. Although with today's computers, more operations would be required to ensure security. This code can then be sent off to your recipient. Now, the key here is that the recipient needs the inverse code that you've used to encrypt. So what we need to do is work out the inverse of the 3 by 3 square matrix. So to work out what your decode key is, you first need to find the determinant of your key matrix. So what you need to do is expand the first row, simplify, and solve. The next part is to find the cofactors of the remaining numbers. This then becomes your decoding key. So as long as your recipient holds this code, they can then decode anything from you, and they can then code their own text, which you will be able to decode with your original key. You might be thinking, well, this is great, but where would this actually apply in the real world? Well, this concept is not new. It has been around for thousands of years, way before computers were even invented. The first known use was from ancient Egypt in the form of hieroglyphics. Another important way cryptography has been used was during wars. Military would send encrypted messages with military operation details, which would have to be decoded at different bases, with assistance from a decoding book. This way, if a messenger was intercepted by enemy lines, they would be unable to understand the plans. Today, cryptography can be seen in the form of sending private documents and signals via the internet. You can also see this being used when downloading new software programs. The technology of cryptography is ever evolving to keep ahead of technology. However, it needs to ensure when manufacturing new ideas and new processes that it has an appropriate balance between practicality and security.